Hey guys, sorry I couldn't be here today, but I want to do a quick overview of probability. Again, probability is always the number of ways to win over the number of all outcomes. It falls between 0 and 1 because you can't have more ways to win than possible outcomes, right? So the biggest probability is 1. Make sure if it's asking for probability, you're giving a number less than 1, unless it's absolutely certain, right? Even if it's a geometric probability, you find the area that wins over the whole area of the entire diagram. So if we have compound events, we might have two or more things happening. You need to ask yourself if there's more than one thing happening, like drawing multiple cards, choosing multiple people, flipping multiple coins, spinners, whatever. Ask yourself, are the events independent or dependent? Independent events are things where the next event is unchanged based on the outcome of the first event. You flipping coins, drawing something out of a bag but then putting it back. That's replacement. If you replace the object between draws, it is independent. If there is no replacement, if you pull something out like a bingo number and then don't put it back, then that is dependent because you've reduced the number of possibilities for the next event. So back-to-back events are either independent, meaning the second one's unaffected by the first, or they're dependent because you've removed something. You've changed either the denominator or the numerator or both. And when you have these two events, you find the probability of each event independently, one at a time. Find the probability of the first event, and then even if it's dependent, you're going to find the probability of the next event, given that the first event just happened, and multiply them. So find the probability of each event, and then multiply them all together to see the probability of that combined or compound event. Now, a different type of compound event is when we have one event with two or more win conditions. And one event with two or more win conditions, is when, like for example, you draw a card, but hope that it's either a jack or a club, but you're only drawing one card. But you have two win conditions. If it's a jack, it's win. If it's a club, it's a win. But you need to ask yourself, do I win if it's either one of those, or does it have to be both? Did they say it must be a jack of clubs, a jack and a club? Or is it okay if it's either a jack or a club? And then the other question you have to ask yourself, is there a condition? So if they say either, that's a union. If either one is a win, if I'm happy to have this or that, then it's a union. I will count all the jacks and all the clubs and be careful not to double count. If I have to have both conditions, then that's the intersection. That's where I am a jack and a club. Jack and a club is the intersection. By the way, the symbol for intersection is this. This is the intersection. The union is the exact upside down one, the one that looks like a U. So this is if either or can be true. This is if both have to be true. I have to have this and that, then it's an intersection. Now the condition was the one where I said given. Am I limited to only choosing from a subset? So given the card is a club, what's my probability of drawing a jack? That means my denominator is changed from 52 to 13 because there's 13 clubs. So let's explore in more depth. We can count the possible outcomes of a multiple event scenario. So if more than one thing happens, you're drawing multiple jelly beans, you're picking multiple people for your team, you are the things where more than one thing happens, You ask yourself independent or dependent, because if it's dependent, you may have to use permutations. But we're always going to find the number of ways each event could happen, then multiply them together. This is the key to everything. Find the number of ways each event could happen, then multiply those numbers together. Whether it's dependent or independent, you're always going to multiply the number of ways each event could happen all together. So how many ways can I pick a soda for my Sonic drink? I might have 3 soda choices. And then how many flavor add-ins do I have? I might have 12. So I take 3 times 12 to get the number of ways I can combine sodas with flavor at Sonic, right? So I multiply those together. But sometimes I'll use a permutation. If it's a dependent event, if what I choose for the first thing changes how many choices I have for the next thing, I will have dependent events and order will matter, then I'm going to use permutation. If I have dependent events and it's a grouping, like I get dealt a hand of cards and I don't care what order they're in because I'm going to rearrange them in my hand, then it's a combination and I have to divide out those duplicates. So, dependent events versus independent. When you were told not to repeat the number, your total available choices were dependent on their choice. So I might have a probability of choosing a 2 of 1 out of 10, but then if I'm not allowed to choose the same number, the next probability is going to be 1 out of 9. So those numbers count down. That's the sign of a permutation. But if they are, if they're independent, dice rolls are independent, right? So the probability of the second roll didn't change. It doesn't matter though, I'm still going to multiply the probability of the first event by the probability of the second event, whatever it is. For either of these, my probabilities get multiplied to see if my probability of a 2 and then a 5, to see what that is. So these are independent events. Probability of the first is 1 out of 4, the second is 1 out of 2. So together, that probability of those two things happening, that compound event, is 1 over 4 times 2. If they're dependent now, then my probability of the first event, probability of the second event, I still multiply each of those, right? I have 4 aces in the deck out of 52 cards, but once I draw an ace, then I take the probability of the second event. Now there's only 3 out of 51 cards, but when I multiply those together, I get the probability of the combined event. So, basic tables. Now this comes from, I'm going to take one thing. I want one thing. My probability of a win is if I pick cats. If I pick one person from this table and they are a cat lover, that's 36 out of the total 100. Or if I have the total columns, it's 36 from the total column out of the total 100. But now I have a compound event. That was a simple event. I just took all the cat lovers over the total number of people. Single event. Now I have a single event with multiple possible outcomes. Makes it compound because there's multiple outcomes. So if I prefer cats and I'm female, then I live at the intersection of cats and female. There we go. Intersection of cats and female, just the number. If I have to prefer cats and be female, then it's just the number at that intersection over the total possible. For union, I need all of them. I need the 10, the 20, the 26, and the 6. Now remember, if I picked from the total columns, if I picked the 36 and the 52, I would have to subtract one of the 26s that got double counted. So be careful with unions. But But that's when I'm happy for them to prefer cats, so either of these is happy, or be female, so all three of these is happy. Intersection looks like this. Union looks like this. Intersection, union. Okay, so conditional. The last thing you need to ask yourself is, did I limit my choices because something is given to me? The probability that a randomly selected female student, you're told they are female. You are given the fact that they are female. So now all of a sudden your denominator went from 100 to only 52. So your denominator is now 52, and the likelihood that they preferred cats is the one that falls under the cats category. So hopefully that helps. We read that as cats given female, and good luck on the quest. Be sure to ask Mrs. Swanson if you need any clarification.